Before we get to the greetings part and the introduction to this talk, I would like to see a show of hands to just understand how everybody codes today. How many of y'all use AI ID tools to code? Can I have a, wow, I like that. Okay, I'm not the only one then. And how many of these are VS Code forks, or is it a VS Code fork that you are using as your AI ID? Okay, and how many of y'all are using Copilot? Oh, interesting. Do we have any supreme elite leaders who do not use any AI tool right now and just, oh my God, okay, that's amazing. My condolences to you. But yeah, this is a very interesting stat that I recently, it was all over Twitter, X, whatever we want to call it. It was all over that, where YC was telling that for 2025 year, from 25% of their startups, 95% of the code has been written with AI, by AI, whatever we want to know. So we are at this stage where this is very, very common, and everybody writes code with the help of AI. So yeah, this was some context I wanted to sit in before we start our talk. Well, come on. Perfect. So today we'll be understanding how do all of these IDEs work? What does it mean when we chat with our code? And we'll see how things happen on the back end. When I say back end, I don't mean databases or something, but things that are beyond the UI, what happens logically. I'm Pratim Bhosale. I work as a senior developer advocate and developer experience engineer with Treble. Treble is an API intelligence tool, and if your product is an API-first product, if your customers buy your APIs, then this is something you should definitely check out. And I think, yeah, that's all about me. So this is a random question. How does re-ranking work in this code? So when we all get into a new code base using our AI ID, and we want to understand how things work. I remember back when I started my developer journey, what I would do is I would be given multiple specs, I would be given an internal wiki, I would be told to read the docs, and then I would be handed over to a senior developer, poor guy, poor girl, I would be just handed over to them. And then I would bombard them with questions. How does this function work? Why are we using this variable? And yeah, it was Java, so it was more painful. But now, how I do it is I take a question and I put it in the chat section of my IDE and ask, how does this work? Or how does a function work? And I'm pretty much sure all of us do it. The ones who put your hands up, that's how we all do it. We ask our AI ID, how do I do this? Or what is this? Literally, we sometimes even get quite abusive with our AI IDs right now. Like, I don't know, I do. I don't know about you. Before we unpack all of these things, I'm going to show you a demo of what I mean and how does chatting with your tool IDE look like. This is my Rust code, and I'm just running it for now. And once the program runs, I've built a command line tool which basically helps me to index whatever data I have, whatever code that I have. Then once the indexing is done, we'll come back to this later, so we'll talk about this in depth, but I just wanted to show you all, give you a hook about what we're doing. So I first index the code, I store it on the disk, and then I load the index. You can name whatever you want to the index, and here. That's when I put in a query that I want to ask my code base. So we saw the question before, how does re-ranking work in this code? Now, this is something I've purely built. I'm not using any cursor tool here. And it also streams and gives you the same vibe as you have it in ChatGPT right now. And yeah, it first gives you the complete context, and then it tells you like where exactly is the re-ranking being used. Now, the cool thing about this demo that I've built and this project that I've built is it not just tells you the context or what it answers your question, but it also gives you references directly to what piece of code that is, what file it is coming from, and how many chunks I've made. You won't need chunking and all of these things to understand while you're asking questions, but we're going to understand why everybody will slowly have to be here, where like building your own tool. So yeah, that was it about just a quick demo. We're going to wait until this is done. Yeah, you just saw that now we all talk to our code in plain English. And we've been doing this for a long time now. It's not this month or last month. We've been doing this for more than a year and a half, or since OpenAI became the whole big deal, since AI became a big deal. We first had ChatGPT initially before the smart AI IDs came in. I used to take code snippets, I used to copy them, I would put them into the ChatGPT context window and ask my questions. And then we came to a point where we got addicted to it, and the context window wasn't just enough for us. And boom, by that time, luckily, we had the IDs come into picture with more context there. So what AI IDs currently do, or the whole concept of chatting with your code base majorly involve, is a few building blocks around understanding written words, understanding English, or understanding any language. And the building blocks for chatting with your code base, some might even call it RAG. You can call it that. It doesn't really matter what you want to call this. But these are a few building blocks of chatting with your code base. The first one is indexing. The second one is re-ranking. Then there is something known as hide. The hide concept is something that I really found interesting, and you should definitely look it up more. And abstract syntax tree. Has anyone before played around with AST? That's okay, that's cool. And yeah, vector search. How many of y'all know what vector search is? Okay. Oh, that's a good amount of hands. So I would just like this to sit in here for everyone to. This is one of my favorite quotes from Twitter. I get all my philosophical stuff from Twitter. We spoke about these AI ID tools. From them, has anyone come across this kind of an error before on your AI ID tool while you were putting in messages? Oh, that's cool. So I want you to focus on the keyword codebase search. The tool call timed out after 5 seconds, and then it highlights codebase search. So what does this mean? Now, I personally do not have access to internal product documents of any of these IDs, but my understanding, based on what I've understood and studied, is what this means is in the pipeline of the tool, a first call is made to a search tool, and once the code has been indexed, that's when the LLM takes that indexed code and gives you the right answer. So if the tool call doesn't happen, then your LLM is never going to get more context about your query. What happens in such examples and cases is AI IDs then move to the most common way of searching. Can someone tell me what's the most common way of searching which we use in our CLI? grep. That's what. So AI IDs then move to a simple grep search. And grep search is not expensive. It's for none of us, for any of the tools. It's part of our CLI. But vector search can get expensive as you want to make it more precise. So my hypothesis and my understanding is, which surprisingly was to some extent made, I could validate it yesterday by a big announcement by one of the AI IDs about them building a software engineering tool, SWE1. I'm not sure if anyone's been catching up with Devin/type of Devin products coming out. And it came out literally yesterday, and this presentation that I had built is a few days old, and it just sits on point. The point is that I personally don't think vector search is that of an interesting thing for companies to work on, like AI tools to support as much, not because it's not precision focused or something, but it doesn't make economic sense for a lot of products. Now, please don't quote me on this, because this is my hypothesis. Why I have come across this hypothesis is because now companies can bulk negotiate LLM rates with bigger LLM companies. And I think we all have seen this recently, where a few models were free for us to use via AI tools. And this is just an example of how LLM calls and queries will get cheaper and cheaper and cheaper for companies to use. So there will be a point where instead of first doing a level of vector search internally, they will just send the query directly to LLMs. And we all know that context windows are also getting bigger. So this is something that we will see a point where vector search would make sense more to you as an individual developer rather than the product or the tool that you're using. And why I say that is, while this will all get cheaper for companies to use each other, and the front-end experience of using any of these tools will get better, you won't even know how the search works internally, how they're catering and custom working on your query. But the moment you hit limits is when it's going to hurt you. The moment you start going through Cursor, or I had planned to not take any names, but going through any hit limits for the pricing, you'll come across a point where we will all be very used to talking to code via search, but search will also cost you money. The end point is search for an individual developer or us shouldn't cost us money. It should be free, and that's one of the reasons why a tool like this will definitely make sense for you to use on your local code. It can stay with your proprietary code and anything. Now, the one that I have built does use OpenAI for LLM, but that's because I didn't want to come into Ollama issues right now. But you can obviously swap it for Ollama. So the first part of building this tool is, the tool is built in Rust, and everyone's like, why would you choose Rust? Like, the whole ML ecosystem is so well in Python. Well, one of the things we had another talk from Colin, and Colin very well shared the good and the bad parts about Rust. But let's be honest, no hate for anything, but pip really sucks. It has a lot of things to catch up, and I personally love Cargo. And if anyone does anyone else feel that Cargo is better than pip? 1, 2, 3. Okay, I have some people with me. Another really cool thing about Rust is the portability. Like any application that you've built with Rust, you can run it on browser, different applications, and everything. So that's with the help of WASM. You can have the binary run anywhere. It is not dependent on the environment. Well, the other things are pretty much known to everyone, that performance is comparatively better while not running. The first execution can be time-consuming, but once you have the binary, performance is really good. It does take in consideration all your cores. So overall, most of the companies today have started adopting Rust. If you were part of the previous code, you did see the talk. Rust is used by big companies like Twitter, NVIDIA, Hugging Face, Google, Amazon. So Rust is there. It's being trusted for its performance, and I personally feel the machine learning ecosystem definitely should slowly start considering Rust as a sustainable way of building applications as well. This is the basic flow and diagram of the tool, or any chat with your code base kind of tool that you could build in CLI. So for my tool, the flow looks like it's a CLI. You can either index your code from the CLI, or you can either query a code from your CLI. Okay. Oops. Yeah. So the first flow of the CLI is indexing. So you have some code. You use different algorithms that you have currently to vector search particular things and put 1 minute. I'm just going to try to run away from the light. But you generate embeddings, and then you save your index on disk, on RAM, whatever you choose. But we'll also see a little bit why it would make sense to store it on disk for a small project, like an internal tool. And the other flow is query. So when we put in that question of like, how does re-ranking work, the user puts in the question, and there is something known as hide that happens, which means it creates a hypothetical document. Now, please stay with me here. I will be picking up each of these words later. But the flow is, the user asks a question, a hypothetical document is created behind, and this document is again embedded. When the embedded document is then connected and looked in for actual pieces of code that make sense for the embedded document, then there is you don't just stop at vector search, you go beyond that, because you still want to make sure that you have more and more precise answers. So there is something known as re-ranking that takes place. And then finally, after the re-ranked piece of code is collected, that code, the embedded query, both of them are then sent to LLM. So all of this is happening before the query is being sent to an LLM to get the direct answer. And initially, when I was talking about the economics not making sense, so all the top points before the LLM generating an answer specifically do not make much economic sense for IDE products or AI tools which are cloud-based right now, because the end goal will always be to have more calls to the cloud. So we spoke about embeddings and everything, but what does embedding actually mean? I won't go into the very specific details, but on layman terms, you have a few objects, you pass it through an embedding model, and the output that you get is vectors. That means like something like arrays of numbers. That's it. These arrays of numbers is what are then fed to the model, because the model understands numbers. And the first thing when you have text, or embedding can work with text, images, or anything. There are specific embedding models that are also used for code now, but that's not something that we'll be looking at. So point being, embeddings is purely converting any object into a vector. So I spoke about the code being chunked and re-ranking, but what does chunking exactly mean? As the word specifically says, as the verb says, chunking basically means taking your code base and cutting it into parts. Like you have a piece of bread, you cut it into small parts. Now, how do you define that small part? What is a small part for you? What is a small part for me? So it all depends on the model that you're using and what chunking size that model supports. There are models that support bigger chunking size. They will take in more processing power. There are models that support less chunking sizes. So it all depends on how much processing power, what resources you have at your hand. After the code is chunked, there is something known as tree sitter that is used for parsing the code. Now, what does parsing mean is actually understanding what does that chunk mean and making some sense out of that piece of chunk of code. Does anyone know what a tree sitter is? Oh, nice, interesting. So I really love tree sitter. Like, as someone who likes visual learning, is a fan of visual learning, when you try out tree sitter, you will see how code is chunked and how your code is converted into an AST. Now, the algorithm that is used here is known as dirwalk. Dirwalk is a very interesting algorithm for you to learn in terms of understanding how can any piece of logic travel through repositories. The whole algorithm is about traveling through repositories and understanding what is the root, what is the multiple stages of, what are the multiple branches under a tree. The current code that we've built has the logic only to parse through Rust files. So it specifically looks for Rust files, and then it will chunk them and convert it into an AST. But this is a limitation of my code. You can always have a tree sitter, and you can include support for all other languages. And finally, once we get these chunks, we store them. We store them as tuples so that we can then re-rank them. We can then use them for getting the right answer. So yeah, we briefly mentioned tree sitter. All languages have grammar. And why should code be separate from that? Code as well has grammar. So how do we make sense of the grammar of code? This is where AST comes into picture. This is where even a semicolon, a comma, everything has a position and a reason in your whole tree. And if you have a tree sitter, it's easier for you to go through the complete tree and parse the code better. So once you use a tree sitter, one of the cool things about tree sitter is that you can change it incrementally. You don't have to wait for a completely new cycle. If you change anything in the code, your tree sitter will change the AST right incrementally and at real time. So I have another live demo for showing the tree sitter flow, but let's come back to this later because I think it will again cause some chaos. But this is the link for a playground of tree sitter. It's pretty cool. You can put in any piece of code into that, and then you can follow the steps of where does a semicolon come in, how does a function look like in. A good way to even visualize a tree sitter is looking at a family tree. So and the root being the whole family, which we don't count. In the tree sitter, the root is, in the AST tree, the root is your main code, and then you can go down as in depth you want. So we have so far understood what embedding is. We have so far understood what tree sitter is. Where does it sit into the picture? We have seen what an AST is. We know how the query flow works like in this tool. We also have seen how the indexing works like. But now when we are talking about indexing, we need to talk about vector search, because we are all talking about how semantically what we're indexing would make sense. How will the code understand, how will your tool understand what the code does, or what is the meaning of those words? ANN is approximate nearest neighbor. One of the algorithms that is used for vector search. How many of you have worked with ANN or used ANN in your functions? That's cool. I think this is something that's a start of the whole information retrieval domain. And under ANN, then you also have HNSW, which you use for full text search and everything. So anything search related comes under one of these algorithms, whereas and specifically for vector search, ANN is the biggest umbrella that you can have under. As I mentioned, it is vector-based similarity search. What does ANN purely mean is when you put in a query, your query is first converted into a vector. Now, your vector in the space will be a point. So ANN helps you to find the closest point to that point. And this concept of finding the closest point is basically finding the most similar thing to that point. Now, ANN does not mean the exactly similar one. It means the closest one. That's why there is the word approximation, because there are examples and use cases where we don't care about finding the right answer. We care about finding the best case answer or the best possible version with time. So if you want to specifically go through each point, that would have you some performance issues, and it would specifically take more time. But that's why ANN comes into the picture, and you can get the closest and the most similar answer to your query or your vector. Now, there is a lot you can go into the data structures for vector search. And one of the things from vector search is that you can always build your very simple you can build your simple vector search. It's a struct. A struct can have one vector, the different sizes and different areas where you save your code. So I would highly recommend trying out building your own vector search or a vector database. I will share the repository which has a single page, a single code where you can reproduce it. Coming to the meatiest part of the talk, I spoke about us using Rust for this, which means we need a ML platform for that. And for this, Hugging Face has authored Candle, which is a Rust framework. And other than Hugging Face, it's quite stable. It's quite portable again. And as I mentioned, the same effects and advantages of Rust are given by Candle. Now, you can either choose Candle to use directly out of any other library support, or there are a lot of crates that you can directly use in libraries. We also touched up on a concept known as hide. So what does hide mean? Hide stands for hypothetical document embeddings. Your query and your code. So your complete code is first chunked, and a hypothetical similar code for each chunk is put into a document named as hide. So first, this hypothetical document is taken, your query vector is taken, and they are first matched together to find a similarity. And from that similarity, then the code is sent to LLMs. So there is another level of precision that comes into picture to make sure that you're coming to the best search of your query. So for example, if the question was, how do I handle errors in this code base? You don't have any context, anything. So what hide would do is, it would create a hypothetical code. It would embed it again into an vector, and then this vector would be used to find similar actual code base, similar actual chunks of code in your code base. Well, and the final would be then these hypothetical chunks being used to find the real examples from your code. One of the last steps is, okay, now we've chunked the code. We've used vector search to have the most similar answer. We also have a section of hypothetical. We have a section of hide, but finally, we use something known as re-ranking, which is nothing but going through the final list of searches that you have to again use another section of search on that, and to make sure that you have come to the highest level of precision for every question. So you have hide and re-ranking, which stand for two different levels of precision that stand between the query that you send to your IDE tool and the final answer that you get. Okay, come on. Okay, yeah. We spoke about embeddings. We spoke about converting your query into embeddings. Now, there are multiple embedding models out there. One of my favorite resources is this on Hugging. It's from Hugging Face, and it's known as the MLTB Embedding Leadership Board. I have added this to the whole repo of examples and stuff, so you should check it out. The tool that I have built uses one of the most smallest and not really great precision embedding models. It literally stands 1/40th on the whole leaderboard. My reason to use that was because I wanted to build a small demo project, but you can swap it up for better ones. Of course, that will need you more resources, but the one that I used was quite good to go on my Mac. So, if you remember the demo that I showed you before, our implementation is different. Like, the implementation that I built is different because it just doesn't give you a vector searched answer, but it adds the references to the actual line of code where you can go and check it out. So this is what I find interesting as an internal developer tool. So if you're building something, I would definitely recommend adding different kinds of customizations to your tool. Now, some other tweaks that I did to my code is adding a little bit of streaming to give it the ChatGPT kind of feeling of you don't have to wait for the answer, you don't have to stare at it. It will be streamed as the output is coming. And yeah, I saved the index on the disk to make sure it's persistent, so that even if you build the index once and you come back to the code later, you don't have to again build it. So that's one cool feature. It also has its own give and takes, but if this is something that you're interested in. Now, the limitations of a tool like this, when you build it for your own work, could be like having a context window which is smaller, but that's okay because you are using vector search, and this is all hopefully free. As I spoke before, we are only using Rust, so we are only considering Rust. But if you want to push the tool ahead, you can definitely add support for other languages. And yeah, there are other things, like depending on the model that you're using, the chunk size will change, and depending on the memory, like this is not an agent. We haven't built an agent right now. We've just built a tool, so it won't have any memory of your previous question. Well, that's the end of all the different parts of the topic and the tool. I was going to go and give a live demo, but I think it's the same demo that I showed you earlier, but we would have done with another query. This is the repo. It's an open source project that I am going to support and follow and build. So do check it out. If you like it, do drop a star. This is going to be the first project that I'll be supporting myself and building. And yeah, that's all from my side. Thank you.